Welcome to the season premiere of Mystery Math. Today we have on the show the esteemed, the knowledgeable, and the great mathematicians Tanmay, Arthi, Swara, and Aaron, who will teach you about rational functions so that none of you cry during your next Algebra 2 honors test. To decide who gets which equation, we shall be picking a name and a function randomly. If our contestants fail to adequately teach you about rational functions, then they will be doomed to the hells of the mathematical world. First up, we have Arthi, and she gets the function x squared plus 4 over x squared minus 4. Next up, we have Aaron, and he gets the function x squared plus x minus 6 over x cubed minus 5x squared plus 2x plus 8. Next up, we have Swara, and she gets the function 3x squared plus 12x plus 9 over x squared plus 5. Last, we have Tanmay, and he gets the function x to the 4th minus 3x squared minus 4 over x cubed minus 8. A rational function is an algebraic function such that the numerator and denominator are both polynomials where the denominator is not equal to 0. Graphing these functions requires us to be knowledgeable about their fundamental characteristics. Most rational functions have vertical asymptotes, which occur at zeros of the denominator. Horizontal asymptotes are a bit more complicated. If the highest degree of the numerator equals the degree of the denominator, then the horizontal asymptote occurs at the leading coefficient of the numerator over the leading coefficient of the denominator. If the highest degree of the numerator is less than the highest degree of the denominator, then the horizontal asymptote occurs at y equals 0. If the highest degree of the numerator is greater than the highest degree of the denominator by 1, then there is a slant asymptote. Symmetry is also extremely important. If you end up with the same equation when the x's in the function are replaced by negative x, then the function shows y-axis symmetry. This is very helpful since every x value, positive or negative, will have the same corresponding y value, making graphing a less harsher punishment. If you end up with the same equation when the x's are replaced by negative x and y's are replaced by negative y, then the function displays origin symmetry. This also makes graphing a lot easier since every point will be reflected over the x-axis and y-axis. For example, if there is a point 1, 2, then there will be a point negative 1, negative 2, unless an asymptote occurs at either x equals negative 1 or y equals negative 2. Finally, x-intercepts are exceptionally important. Set the function equal to 0 and solve for x to find the x-intercepts, and evaluate the function for f of 0 to find the y-intercept.
A function is f of x equals x squared plus 4 over x squared minus 4. You factor the denominator, you get x plus 2 and x minus 2. For your vertical asymptote, you set x equal to 0, so x equals 2 and x equals negative 2. For your horizontal asymptotes, you look at the degrees of the variables, and since they are the same, you set the leading coefficient of the numerator over the leading coefficient of the denominator, and they're both 1, so y equals 1. For your x-intercept, you set f of x, or y, equal to 0. So you do x squared minus 4 to both sides, and you get x squared equals negative 4. And a square cannot be negative unless you're in imaginary. You can't graph imaginary, so there's no x-intercept. For your y-intercept, you set x equal to 0. So 0 squared plus 4 over 0 squared minus 4 is negative 1, so 0, negative 1. And for your symmetry, you look at both x and y. So if you set x to negative x, and if the equation is still the same, you have y-axis symmetry. However, if you were to set x and y to negative x and y, and you get the same equation, that would be origin symmetry. However, that does not work in this case, so it is only y-axis symmetry.
Okay, the function is 3x squared plus 12x plus 9 over x squared plus 5. So first,